Welcome to this updated MongoDB crash course for 2022. Brad has done a couple of these MongoDB crash courses over the years, and since then there have been some improvements and changes to MongoDB. Since he's super busy, he's letting me create this crash course for him. And let me tell you, his studio is amazing. I'm Jesse. I'm a senior developer advocate at MongoDB. You might also know me from my YouTube channel, CodeStacker. And to be completely transparent, this video is sponsored by MongoDB. And by the end of it, you should have a good understanding and be able to get started using MongoDB in your next project. So what is MongoDB? Well, a lot of times you'll hear MongoDB referred to as a NoSQL database, and that's not really the best way to reference it. Some think NoSQL means not SQL, but it actually means not only SQL. You see, MongoDB can use SQL. SQL just stands for Structured Query Language. It's just a language for querying data. You might also hear MongoDB referred to as a non-relational database. And again, this isn't the best way to reference it because you can store relational data in MongoDB. It's just stored differently than in a relational database. So MongoDB is actually a document database. Data is stored in JSON under the hood, but is represented as JSON. This is fundamentally different from a relational database. Many start with and are familiar with relational databases because they've been around for decades. Relational databases structure data like a spreadsheet. Data is stored in rows and columns, and each row is a record and each column is a record field. And you'll have multiple tables connecting all of the related data together. And relational databases also require predefined schemas. Schemas define the structure or blueprint of how the data should be structured. Schemas in relational databases are strict, meaning that your field types must be defined ahead of time. So you have to define whether a field will be an integer, a string, or other data type ahead of time. For document databases like MongoDB, if you're already familiar with JavaScript, then you'll be familiar with how MongoDB stores data in JSON format. JSON is structured as objects containing key value pairs. We define an object with curly braces, and then our key is surrounded by quotes. And lastly, our value is separated from the key by a colon. The value can be a string surrounded by quotes, a number without quotes, arrays of values using square brackets, or even other nested objects. This way, a single document can store all of the data for each record instead of splitting up the data like a relational database does. Generally, data that is accessed together gets stored together. Now, although the documents that you work with will be in JSON format, MongoDB actually stores the data on the server in BSON format. BSON is an extension of JSON, and it adds support for extended data types. Now, you don't really need to worry about that. It's just nice to know. MongoDB databases are flexible. By default, there is no schema in place. You can store any type of data in any document, and this is by design. If you need a schema to add more structure, it can be added at any time. MongoDB databases scale very easily and are very cost-effective. They're also faster to query data in most operations over relational databases. You can install MongoDB locally, which will allow you to host your own MongoDB server on your hardware. This requires that you manage your server, upgrades, and any other maintenance. You can download and use the MongoDB open source community server on your hardware for free, and I'll include a link for the download and instructions in the description below. But for this video, we're going to use MongoDB Atlas, our cloud database platform. This takes all of the hassle of hosting your own server away so that you can focus on more important tasks. MongoDB Atlas has a generous free tier. Just go to mongodb.com and click Try Free, and there's no credit card required. The direct link is in the description below as well. Just fill out the short form or use your Google account to sign up. Next, we'll choose the type of cluster that we want to create. We can choose between serverless, dedicated, or shared. Serverless instances are a pay-as-you-go type of plan. They seamlessly scale, and you only pay for the operations that you perform. Dedicated is our standard tier and allows advanced configurations and is enterprise ready. Shared is completely free forever and is great for small projects and testing environments. So let's choose that option. Next, we can choose our cloud provider and region where we want our cluster to be hosted. And finally, we can change our cluster name if we want, but we'll just keep all of the defaults and create cluster. And now our cluster is being created, and this usually just takes a few minutes. Now, out of the box, MongoDB Atlas is completely locked down, so you'll first need to enable access. First, in the left menu, select Database Access. We'll create a new user with password authentication. Now, you can choose a username and password or let Atlas auto-generate a secure password. will allow the new user to read and write to any database. And we can even restrict a user's access to specific clusters or make the user a temporary user. In that case, the user would be deleted after a specified duration automatically. Next, we'll go to Network Access in the left menu and add an IP address to our access list. This will prevent access to our cluster from any IP address that's not on the list. We can choose to add our current IP address, allow access from anywhere, or a specific IP address or range. We can also enable temporary IP addresses just like with the users. Now note that allowing access from anywhere is a security risk and should be avoided, especially in production environments. Generally, this IP address should be the one for any production servers or services that will be accessing the database. And now it's time to connect to our database. First, I'm going to show you how to connect using the MongoDB shell. There's a link in the description to this install page. You can install the Mongo shell following the installation instructions for your operating system. After you've installed it, you'll be able to perform some CRUD operations. Now, CRUD stands for Create, Read, Update, and Delete. And first, we'll need to connect to our database. Let's go to Connect in our Atlas dashboard and select Connect with the Mongo shell. And now copy the connection string. Now let's open our terminal. You can use any terminal that you want. I'm using git bash inside VS Code. Now to be sure the Mongo shell is installed properly, let's check the version. So we're going to type mongo sh -- version. And you can see I'm using version 1.1.7, which is the latest as of the recording of this video. Now to connect, let's paste the connection string. And notice in the string that it's connecting to a database called My First Database. And you can change this, but it really doesn't matter. So I'm going to leave it and show you why. After that, we have our username. And when we hit enter, we'll be prompted for the password. And now we're connected. Now throughout the rest of this video, I'm going to reference a bunch of MongoDB methods. All of the ones that I reference will be included in a cheat sheet linked in the description below. And we can see what database we're using by typing DB. It shows My First Database. And we can see all of the available databases by typing show DBs. Notice that we don't see My First Database. And this is because we haven't added anything into the database yet. If we want to use a different database or even create a new one, we can type use and then the database name. So we'll create a new database called blog. And again, this database is not actually created until we insert some data into it. Next, we need to create a collection. We can specifically create a collection by using db.createCollection and then the collection name. Or we could just create the collection on the fly as we insert data. So to create or insert a document, we can either use the insert one or insert many methods. So let's do db.posts.insert1. Now db is the database that we're using. Posts is the collection, and if it doesn't exist, it will be created. Collections are like tables in a SQL database. Now insert1 accepts an object. I have another file open here with a document that I'm going to copy. It has a title, a body, category, likes, tags with an array of tags, and a date, and we can insert the current date by using the date method. And let's run that. Now we can see that it inserted one document. If we want to insert more than one at once, then we can use insert many, and then we'll pass in an array of objects. So I have an array here with more post objects. So I'm going to paste that in. And so now we can see that it inserted all of these documents. But how do we actually see the documents? We can use db.posts.find. So find is going to find all of the documents in this collection. If we wanted to narrow it down, we could pass an object inside of find, which is going to define what we're looking for. So let's say a category of news. So now it's only going to show us all of the documents that have a category of news. And we can also sort. So after find, let's find everything, and then let's sort by title. And then for sort, we're either going to give it a 1 or a -1. 1 will sort in ascending order and -1 in descending order. So let's do -1. And we can see our posts in descending order. We can also count. So let's go back up to our find where we had category of news. And let's add on to that a count method. So now it's going to count how many articles we have with the category of news. And we can also limit how many results will be returned. So if we do a find on everything but limit to 2, it's only going to return the first 2 documents that it finds. And just like in JavaScript, we can chain on multiple methods. Now, similar to find is another method called find1. Now, find1 is pretty self-explanatory. It's going to return the first match. So for find1, we would want to put some sort of a parameter to search for, or we could use one of the many operators. Let's find the first post with likes greater than 3. We also have GTE, which is greater than or equal to. LT and LTE, which is less than and less than or equal to. So it should return to us post 4, which has 4 likes. Now to update an existing document, we can use the update one or update many methods. So let's do db.post.find, and let's look for the document that has the title of post 1. So we can see that this one has 1 in the likes field. Let's update that. So let's say db.post.update1, and now the first parameter is going to be the criteria that we're searching for. So we want to match the title is going to be post 1. Now, normally in a production environment, you would want to set this to match on the object ID. Just for the demonstration purposes here, we're going to use the title. Now, the second argument here is what you want to update. So we're going to say likes 2. Now, notice what happens. In previous versions, this would have replaced the entire document with likes 2 and erased all of the other data. If you want to update just a specific field and keep the rest, we'll need to use the $set operator. So let's do update 1 again, and we're going to use $set. Within $set, we're going to pass the category, and we're going to change it to tech. Now, before, the category was event, so let's do a db find on this one, and now we can see that it is set to tech, and the rest of the data is still there. Another thing that we can do is insert a document if it's not found. So let's do db.post.update1, and we're going to search for a title of post 6. Now there is no post 6. For our second parameter, let's pass in the object that we want to update. So I'm just going to pass in this one, just the title, body, and category. So we'll need to use $set again, and then paste in that object. And we can pass a third option. In this third option, we're going to pass upsert true. So upsert will update if it's found and insert if it's not found. So now if we do db.post.find, we should now see post 6. Another thing we can do is increment numbers. So we can do update 1, and let's search for post 1, and let's increment the likes. And we're going to increment using the $inc operator, and we're going to increment the likes by 2. So now let's do a find. So we'll look for post 1. And now we can see the likes went from 1 to 3. And we can do this across all of our documents by using the update many method. So we're going to say update many. We're going to pass an empty object as the first argument because we're going to update everything. And then we're also going to use the $inc operator to increment the likes. And we're going to increment all of the likes by 1 on all of the documents. Let's do a db.post.find again. And we'll see that all of the likes were incremented by 1. And we can even see that post 6, which didn't have any likes at all before, now has 1 like. All right, so we went over the create, read, update. Now let's look at deleting. We can delete documents by using the methods delete one or delete many. So let's do db.post.find.count. We can see that we have 6 documents currently. Let's do db.post.delete1, and let's pass in the title of post 6. Let's do a count again. Now we only have 5. So post 6 was deleted. Now to delete everything in the collection, we could do db.post.deleteMany and pass in an empty object, but I don't want to do that. So I'm going to put in here category of tech, and now it's going to delete every document that has a category of tech. All right, now I want to show you back in our Atlas dashboard, we can go to Browse Collections. We can see all of the collections and documents that we've added. We have our blog database and our posts collection. And we can see we have a total of 3 documents, just like we had in our Mongo shell. And from here, we can manually add data, edit data, find data, and much more. So I could go up here to insert document and manually insert one. I could go here and edit this document, and I could filter documents. But I want to add some more data for us to use. So we're going to load some sample data into our database. So I'm going to go back to databases. So then here on the 3 dots, we'll click that and then load sample data set. And we're going to load that sample data set, and it's going to take a few minutes. So while that's loading, let's take a look at another way to connect to our MongoDB Atlas database. We're going to take a look at Compass, the GUI for MongoDB. Now there's a link in the description to install Compass. It's free and it works on Windows, Mac, and Linux. So to connect to it, we're going to need a connection string. So let's go back to Atlas and let's click connect. And then we're going to connect using MongoDB Compass. So let's copy this connection string. So this is the first thing you'll see after you install Compass and open it up. So we're going to paste in our connection string, and we need to enter our password. And so I have a super secret password Mongo. And the last part here is the database that you want to connect to. It really can be anything. We'll hit connect. All right, so now we can see our blog database, and we can see some of the sample data is already starting to show up. And from here, we can view and query our data, create databases and collections, create and analyze indexes, create aggregation pipelines, assess query performance, and much more. You'll notice throughout, you may see this admin and local databases. Just don't worry about those. You should never have to mess with them. All right, so it looks like our sample data has finished loading. Also, check this out. We have built into Compass the Mongo shell, just like we looked at earlier. That's super convenient. We have a sample Airbnb database. Let's click on that. And in here, we have the collection listings and reviews. This contains a bunch of rental listings like Airbnb. So let me show you the power of aggregations. So we're going to go over here to the aggregations tab. An aggregation pipeline allows us not only to search our data, but transform it on the fly. We can group, sort, filter, create new fields, perform math operations, project only the fields needed, and so much more. So in the aggregation builder, we can create multiple stages and then see the data along the way. So in our initial stage, we have all of the data. So let's first get the rentals that accommodate greater than 4 people. In the data here, we can search through and we can see what's available to us. And so we would see accommodates to. And so let's select $match. So let's say we want to find accommodates and we want it to be greater than. So let's say $GT. And we also have GTE, which is greater than or equal to, LT and LTE, which is less than and less than or equal to. So GT4. And now it's going to load a preview of what the data will look like at this stage of the aggregation. So now we should only see listings that have more than 4 in the accommodations field. So let's add another match. This time we want to say price is less than 500. And we're going to do that on the price field. And we want to say it is less than $500. All right. And so we'll get another preview. Now all of these should have a price. Let's find the price field. Go more. Price less than $500. So let's add another match. This time we want to look at the amenities. So if we look in here, we can see that there is an amenities array. And within the amenities, we have all the different amenities for this property. So let's do another match. And in this match, let's match on amenities. And let's say we want to make sure there is a hairdryer. We need that hairdryer. Now everything in here is going to have a hairdryer. Now let's sort our results. So let's scroll down and we can add another stage. So let's go down here and we'll select $sort. And we want to sort on price. Of course, let's sort on price. And then the sort order is going to be ascending or descending. So let's do ascending. So we'll have the lowest price first. Let's find the price field. And this one's $20. So lowest price to highest. And now let's only include the fields that we need in our front-end application. If our front-end application doesn't need all of these fields, then why send all of this data over the internet to our front-end application? So let's go down here. And for this, it's called project. So $project. And we want to tell it specifically what fields we want. So we're going to say we want the name field. And we're going to say 1. That indicates that we want the name field, right? So we're also going to add amenities. And then let's also add the price. And let's add images and description. All right, so now at this stage, these are the only fields that we're going to see in our results. So the last thing we want to add is a limit because we don't want to send possibly 1,000 documents all at once. So let's go down here and let's do $limit. And let's limit it to say 20. Now the order of these stages matters. If we did a $limit first, then we would limit to the first 20 that it finds, and then it would search, match, sort, and project based on those first 20 that it found. And it would just be the first random 20 records that it found. So be aware of the orders that you place these because each stage is going to act upon the data available to it. And you can see there are a lot of different stages that we can add. All right, so now that we have this aggregation pipeline built, we can export this pipeline to a specific language. So we can pick here which language we want to export to. We have Java, Node, C#, and Python. So we'll select Node, and let's copy this because we're going to use it a little bit later. All right, now I want to connect to our data in another application. We're going to use the MongoDB extension for VS Code. So in VS Code, just search for the extension MongoDB for VS Code, and this is an official MongoDB extension. And let's install that. After it's installed, in our sidebar, we should see this MongoDB leaf, and we can add a connection. So let's connect using a connection string, and we'll need to paste that in. So let's go back to Atlas, and let's click connect, and we're going to connect using MongoDB Compass. Even though we're using the VS Code extension, it's going to use the same connection string as Compass. So let's copy that. We copied it earlier, and we'll go back to VS Code, and let's paste in our connection string. Let's remove the test database, and we're going to put in our password, and we are connected. All right, so now we can expand this, and let's just move playgrounds and help down, and we can see all of our databases here. So again, we have our sample Airbnb database. We have our blog database with all of our posts. We can see that there are 3 documents in our blog database and sample Airbnb. We can see that there is 6,000 documents or 6,000 listings there. And from here, besides viewing our databases and collections and documents, we can create new databases, collections, documents, and there's a playground to perform database queries. So right here, we can create a playground, and let's close the sidebar so we can read this. So there are a lot of comments in here to help us out. So this is very similar to the Mongo shell, where we're going to select the database to use. So in this case, it's MongoDB, VS Code, Playground DB. And then we're going to say db.sales collection.drop. So what this is going to do, .drop is going to delete the collection. It's going to basically allow us to start fresh. And then it's going to create a new sales collection and insert a bunch of documents. After that, it's going to perform this find, where it's going to find by greater than the specific date here, and then less than another specific date. And then it's also showing us how to build an aggregation pipeline here. And then it's running our sales aggregation pipeline. Let's go ahead and run this and see what exactly it does. So up here on the right side, we're going to hit play, and it says, "Are you sure?" And let's say yes. And here are the results of the playground. And if we go over to our MongoDB tab, we should now see our new MongoDB VS Code Playground DB database. Inside that, we should see sales. And then inside that, we should see the 8 documents that it created. If we want to open a specific document and see it, we can do that as well. So it's pretty cool. There's a lot that we can do right inside of VS Code. All right, now the last thing that I want to show you is how easy it is to use MongoDB in an application. So we're going to use Node.js. This time in Atlas, we're going to go to connect, and we're going to say, connect your application. And now here you can see all of the different drivers that we can choose from. So there's C, C++, C#, .NET, Go, Java, Node.js, Perl, PHP, Python, Ruby, Rust, and Scala and Swift. So we're going to select Node.js, and then we have our connection string. But if we click this box here, we're going to include the full driver code example. So this gives us everything that we need to get started in Node.js. So let's copy that, close, and let's go over to VS Code. All right, so I have an index.js file here. Let's paste in the code that we just copied. First, it's requiring MongoDB. So let's go ahead and open up our console. Let's do an npm init-y just to get this project going. And then let's do an npm I MongoDB. So we just need to download that MongoDB package, and then we can get going. All right, so now it's requiring the MongoDB package. We're getting the Mongo client from that. Here is our URI. So this is our connection string, just like before. And we just need to put in our password. So let's go ahead and change that out. Mine is super secret, Mongo. And of course, in production, you're going to want to put this in an environmental variable. And then after that, we're getting our client. Our client is going to be a new Mongo client, and we're passing in our URI. And then we're going to call client connect. Once we're connected, then we can get our collection. So we're going to say client.db. And so then we need to specify what database we want to use. So let's use the sample Airbnb. And the collection was listings and reviews. All right, so now we have our collection, and now we can perform actions on the collection. So we can do that right here. And let's use that aggregation pipeline that we created earlier. So let's create a const called pipeline. And that's going to equal, and I have it right over here. This is the one that I copied earlier. So let's copy that, and we're going to put it right here. All right, so this is a really long array of objects where we're doing our match, where we're matching the accommodations greater than 4, price less than 500, amenities of a hairdryer, price sorted, and then all of these fields projected, and we're limiting to 20. All right, so then after that, we can say collection.aggregate, and we're going to pass in our pipeline. All right, and then at the end of this, we need to turn this into an array. And let's assign this to a variable. Just assign this to ag. And let's just console log this. And since we're dealing with promises here, we're going to await this. And of course, if we have an await, we need an async. So let's go back up here. And let's say that this is an async function. Let's save that. We'll open up our terminal. Let's do node index. And there we go. We have 20 documents that it just gave us. And of course, we only have the images, the price, the amenities description name, and it passes along the object ID as well. So it's pretty easy to integrate MongoDB into your application. So we looked at how to get started with MongoDB. Using MongoDB Atlas, we learned different ways to connect to our database. We used the Mongo shell, Compass, VS Code, and our own Node.js app. We covered how to perform CRUD operations and dove into aggregation pipelines. And this is just scratching the surface of what's possible with MongoDB. You should now know enough to get started using MongoDB in your next project. If you have any questions or issues, go to community.mongodb.com. Our community and staff are there to help. Let me see what else I can get into around here.